This audiobook will cover lessons 10 to 14 from the Geography Coasts booklet. Additional information was procured from worksheets and PowerPoint presentation. Lesson 10: Transport and Deposition. Traction. Relatively large and heavy rocks roll along the seabed, pushed by waves and currents. Solution. Dissolved material is carried in the water as a solution. This type of sediment transport is of limited importance on coasts. Saltation. Smaller and lighter rocks bounce along, either due to the force of water or wind. On a dry, windy day, a layer of saltating sand is often seen 2 to 10 centimeters above the beach surface. Suspension. Silt and clay particles can be carried along in the water. On soft rock coastlines such as Holderness, the sea is often muddy brown in color due to suspended sediment. A berm, a raised ridge of pebble or sand found at the high tide mark. They are found in the backshore area and usually are formed from materials deposited by storm waves. The highest berm is called the storm ridge, but it is worth acknowledging that a beach can have several berms. An offshore or longshore bar. These are ridge parallel to the shore and are a short distance out to sea. They can be submerged by seawater at high tide but exposed at low tide. Spits. Spits are long, narrow stretches of sand or shingle with one end joined to the mainland and the other extending out to sea. They can also be partway across a river estuary. However, we need to know how a spit can form. Number 1. The formation of a spit begins due to a change in the direction of coastline, e.g., a river estuary. Number 2. Longshore drift brings material from further down the coast and starts to build up across the estuary. Number 3. The outward flow of the river prevents the spit from extending right across the estuary mouth. Number 4. The end of the spit might begin to curve due to a secondary wave and wind direction. Number 5. This is known as a recurved spit. Lesson 11. Sediment shell concept. Sediment moves along the coast in sediment cells. Within each cell, the sediment moves between the beach, cliffs, and the sea through the processes of erosion, transportation, and deposition. Any action in one place, for example, the installation of groins, has an impact elsewhere in the cell. Each cell operates between physical barriers that prevent the sediment from moving further along the coast. An excellent example would be major headlands or rivers. The coastline of England and Wales is divided up into 11 major sediment cells. The amount of sediment available within a sediment cell is called the sediment budget. Sediment cells operate in a state of dynamic equilibrium. In other words, erosion in one place will be balanced by deposition in elsewhere. If the amount of sediment entering into the system is reduced, erosion will increase. If the amount of sediment entering the system is increased, deposition will increase. We must also cover the Nile Delta case study. A delta is formed by the deposition of sediment at the river mouth. The River Nile's delta, found in Egypt, stretches for about 240 kilometers. Over half of Egypt's population live on the delta. This coastline is experiencing rapid coastal retreat, with significant erosion taking place on at least half of the delta. A third of the delta is classified as highly vulnerable. Contemporary sea level rise linked to human activity of 1 meter by the year 2100 could lead to the loss of 2 million hectares of fertile land and the displacement of 6 million people. The construction of the Aswan Dam in 1960s has significantly worsened the situation. Sediment volume was reduced from 130 million tonnes to 15 million tonnes. Finally, erosion rates in some places jumped from 20 to 25 meters per year to over 200 meters per year as the delta was starved of sediment. Lesson 12. Sea level rise, eustatic change, global. This is a global rise or fall in sea level relative to the land. In cold glacial periods, water becomes confined to the land in the form of snow and ice. So sea and ocean levels fall. The English Channel was dry during previous glacial periods. During the last ice age, the Pleistocene, 8,000 to 12,000 years ago, sea level was at least 120 meters lower than it is today, creating more land surface. We are now living in an interglacial period, which tend to last around 10,000 years, where sea level has risen relative to the land due to the melting of land-based ice and snow. Isostatic change, local, isostatic subsidence. During glacial periods, the enormous weight of the overlying ice on land makes the land sink subside by compression. De-isostatic recovery during an interglacial. When the ice melts, the land begins to rise up again, rebound. This is called post-glacial adjustment. Given this information, do you know what are the long-term causes of sea level change on the British Isles? Eustatic sea level change is global and relatively quick. When the last glacial period ended, a rise in meltwater formed the North Sea and English Channel. Isostatic sea level change is local, slower, and more complicated. You also need to know that land in the north and west is rising and that land in the south and east is sinking. The whole country acts like a giant seesaw, and combined with rising global sea levels, subsidence in the southeast is why London faces an increased risk of coastal flooding. This brings us to isostatic change, also called accretion. In river estuaries, when sediment is deposited, the weight of sediment can make the land subside. We say that the sediment is accreting. In conjunction with post-glacial adjustment, this is another isostatic factor, increasing the risk of coastal flooding in the River Thames, which flows through London. Why are some coasts at risk from contemporary sea level change? Number 1. Thermal expansion. Seawater expands as it warms. Thus, in a warmer world, this will add to eustatic change. Number 2. Melting of ice on land. More water is added to the oceans due to ice on land melting. For example, the Greenland ice sheet and glaciers. Number 3. Tectonic activity. Tectonic uplift and local tilting of land has created sheer cliffs. For instance, some ancient ports in Italy are now stranded above sea level. The 2004 Boxing Day earthquake caused the Indonesian city of Banda Aceh to sink and subside, permanently flooding parts of the city. The tectonic movement associated with this massive earthquake caused a permanent sea level rise of 0.1 millimeter in the Indian Ocean. Lesson 13. Emergent and submergent coastline. Raya is a drowned river valley which has been partially submerged due to flooding from the sea. In plain view, they have a branching pattern. Rayas are more common along discordant coastlines, where strata are at right angles to the coastline. While rivers were able to erode more deeply downwards in glacial periods with lower sea levels, once sea levels rose, the valleys are filled. Rayas can be found in Cornwall and southwest Ireland. A specific example would be the Kingsbridge Estuary in Devon. Fjords are drowned glacial valleys which have been shaped by the action of ice and submerged due to sea level rise. Fjords have steep sides and flat bottoms, typical of the U-shaped valleys of glaciated landscapes. These are narrower than rayas. Fjords may have hanging valleys and waterfalls. Fjords have a shallow entrance called a threshold. A specific example would be Hardangerf Fjord in Norway. A Dalmatian coast is similar to a raya, but may be formed when rivers flow almost parallel to the coast. They are formed on concordant coastlines where strata is parallel to the shore, alternating ridges and valleys that are submerged when sea level rises. Wide, open bodies of water called sounds develop, which have islands or ridges of raised land between them. A specific example would be the Dalmatian coast of Croatia, a raised beach. It is an emergent coastline formed due to isostatic recovery and rebound due to the melting of glacial ice 8,000 to 12,000 years ago. The land is rising at 1.5 millimeters per year, consequently bouncing back after being compressed under ice. They are often seen with a relic or fossil cliff. A specific example would be the Isle of Arran in Scotland. Lesson 14. Coastal flooding in developing countries. Coastal flooding in Bangladesh. Bangladesh is the world's most densely populated country. It has a population of over 165 million people. Its GDP per capita was $4,200 in 2017. Bangladesh is the country most at risk from sea level rise. Up to 40% of its farmland could be lost by 2100. A 1.5-meter rise in sea level would displace approximately 16 million people. Climate change could also increase the severity of tropical cyclones and the frequency of storm surges. Bangladesh is a low-lying delta, being only 1 to 3 meters above sea level. Almost 50% of its population lives less than 10 meters above sea level. Its land is sinking a few millimeters per year, with some islands having sunk by 1.5 meters in the last 50 years. The clearing of vegetation, particularly mangroves, means they cannot protect its coastlines against erosion and flooding. In fact, the largest remaining mangrove forest is found in the Sundarbans region of Bangladesh. 70% of this mangrove forested coastline is retreating by up to 200 meters per year. There are also high tides in Bay of Bengal. For reference, these are all local factors. Another case study would have to be Kiribati. It's made up of 33 coral atolls in the middle of the Pacific Ocean. It has a population of 110,000. Sea level rise and storm surges due to climate change have increased flooding and erosion and contaminated water supplies. It is possible that people of Kiribati will become environmental refugees. Over half of the population live on the island of Tarawa, where the maximum height above sea level is 3 meters. Scientists estimate the risk of flooding in Kiribati will increase by 200 times between 2000 and 2080. Sea level is rising at 1.2 centimeters per year, 4 times faster than in other locations. 75% of the island of Tarawa could disappear by 2100, with a 50 centimeter increase in sea level. In 2014, the then Kiribati president, President Tong, purchased 20 kilometers squared of land in Fiji to use mainly for agriculture and fish, farming to help increase food security. The land means that the government will also be ready to relocate its population if necessary. The government also launched its Migration with Dignities campaign to allow people to apply for jobs on offer in neighbouring countries such as New Zealand. Lesson recap: low and high energy coast. Low energy coasts are calm, sheltered, and are home to constructive waves. They have a short fetch and deposition occurs. Sediment inputs are very important, and you can expect to see beaches and dunes, mud flats, and salt marshes. They are also flat and have low-lying relief. High energy coasts, on the other hand, are exposed to storms and destructive waves. They have a long fetch and are vulnerable to erosion processes. Its sediment output is very important and are typically categorized by cliffs, wave-cut notches, and platform stacks and arches. They also have a high relief and a rocky coast. Eroding coasts are home to marine and subaerial erosion. They have an annual rate of both erosion and recession of 1.5 meters per year. A perfect example would be Yorkshire's Holderness Coast. Outbuilding and accreting coasts, on the other hand, see the deposition of sediments. In the last 10 years, 100 meters of salt marshes and sand dunes have formed, another good example of which would be the Sefton Coast in Birkledale, a place near Southport. Concordant coasts are rock bands which run parallel to the coasts. They have equal rates of erosion and yield a straight coast. Their contemporary discordant coastlines have rock bands which lie 90 degrees to the coast. They have different rates of erosion and create bays and headlands. Submergent coasts are formed when land has or is being flooded, especially from eustatic rise. The Thames estuary, for instance, is sinking by 1.5 millimetres per year. The famous fjords of Norway would also suffice as an example. Accretion is common here. Finally, emergent coasts are areas of land which have or are rising above the sea. This occurs because of either tectonic activities or isostatic changes. They rise by 1.5 millimetres per year, and a prime example of this would be the raised beaches found in northwest Scotland.